Hi guys, in the class we skipped this particular topic, fast modular exponentiation. What is this all about? This sometimes can be useful if the power is kind of big and also this modular is not small. So when this happens, this technique can be useful. Of course, there are some other better techniques out there. This is just one way to solve this problem. For instance, this problem actually can be solved using the Chinese remainder theorem. I would create another separate video to show how that can be done. But in this video, let's focus on this particular technique. How does this technique work? First of all, we want to write this power into binary notation. So write 644 into binary notation. And later on, you will see why we do that. Okay, so let's first do this. Now, I actually created this table just for the convenience of writing this 644 into binary notation. So let's take a look at that. First of all, 644 does contain 512, right? So therefore we do have 512. If you do the algebra, 644 minus 512, so we have 132. And 132, 256 is larger than 132, so we don't have 256. Therefore, we should have a 0 here. 128 does go into 132, so therefore we should have 128. So 128, let's which is 4, right? So 4 means we don't have 64, 0 for 32, 0 for 16 and 8. We have 1, which is 4, and 0 for the other ones. So now we have 1 0 1 0 0 0 0 1 0 0. Now why do we do this? This means this 264 is equal to 2 to the, now 644 means we have 512, and then we have 128, and we have 4, right? So basically this is 2 raised to 512 times 2 raised to 128 times 2 to the 4th. Okay, so what's the purpose of writing this into binary notation? That's the purpose. It helps us write this 644 into those powers. Those are the powers of 2. And then why do we do that? Let's now look at the actual computation. Okay, so we are going to begin with the powers of 2. 2 to the power 1 is actually congruent to 2, right? Mod 645. So for all the following calculations, we are going to always mod 645. So allow me to skip this, otherwise it will be a little too much to write. So now the 2 square, just square the previous one, which is congruent to 4 mod 645, right? And what's the next? The next, you want to square the previous one. So you're going to do the 2 to the 2 square and then square, right? Which is 2 to the power 4. Now, this 2 to the power 4 is the same as 2 to the, like 2 square. 2 to the power of 2 square, which is congruent to 16. Repeat this pattern. The next one is going to be square of the previous one. Previous one you have 2 to the power 4, and then you want to square it. So this is 2 to the power 8, right? And 2 to the power 8 is the same as 2 to the 2 cubed. Okay, so now so that's why we look at the powers of 2. Okay, powers of 2. And that's why we want to write that into binary notation. These are all the powers of 2. What is 2 to the, basically this is just square of the previous one. What you're doing here is the square of the previous one. Basically it's square of 16, which is 256. Mod 645, it is still 256. And repeat this pattern again. So previously you have 2 to the 8th, right? So you're going to square it, which is 2 to the power 16. 2 to the power 16. And obviously 2 to the power 16, the 16 is 2 to the power 4, right? Okay, so it's actually, you can see that each one is just, the power is just power of 2. Increasing, this is 2 squared, 2 cubed, 2 to the 4th. And what is 2 to the, oops, let me use the correct color. Okay, so now you have to do a little algebra. There's no way that you don't do too much algebra here. So 256 square and then mod 645. This turns out to be, well, you want to pause the video here and then try to exercise yourself on this modular arithmetic, right? So you want to pause that and then check the answer here. So the answer is 391. Again, this is mod 645. And you continue. This is power 16. You have to do that for a while until you have this power. You have power 512. So the next one is 2 to the 16 square, which will be 2 to the power 32, right? And 2 to the power 32 is the same as 2 to the 5th. Okay, this is gonna be 391 square. Okay, you're gonna square the 391 square, and again pause the video and then do the algebra yourself. This is gonna be, the answer is 16 mod 645. And continue this pattern. The next one will be 2 to the 32 square, which is going to be 2 to the 64. So this is going to be 16 square, right? Which is 256. You probably feel that, isn't that when we do see the 16, it will repeat? Actually, you're right. It will just repeat because all you do is you just square the previous one, right? So therefore, you really don't need to do too much algebra now. So you know that the next one is 2 to the power 128. It's going to be, repeat this, 391. 2 to the 256 is going to be congruent to 16. And 2 to the 512 is going to be 256. Again, we don't need to repeat all the algebra because once you see the 16, they should repeat. Now, go back to original question. You already know this 2 to the 644 power is can be broken into these products of these three numbers, and these powers are the powers of 2. And therefore, you can say that 2 raised to power 644 is equal to 2 to the power 512, 2 to the power 128, 2 to the 4th, and which is congruent to, and look up the values from here, right? 512 is 256, so 256 times 2 to the power 128 is 391 times 2 to the power 4th is 16. That's pretty much the algebra that you have to do. If you do all these and at the end mod 645, this actually turns out to be 1 mod 645. Okay, so in a separate video, I'm gonna show you how this same problem can be solved using this fact, 45 is equal to 3 times 5 times 43, and then we are gonna talk about how we can use Chinese remainder theorem to solve this.